Scientists once believed our solar system ended with a bang. Literally. They thought that at the very edge of our cosmic neighborhood, there was an invisible wall of fire, a region so hot it would incinerate anything that got close. They predicted that Voyager 1, our farthest-reaching spacecraft, would meet its end right there, instantly reduced to ash. This wasn't a sci-fi fantasy. It was a real prediction based on a phenomenon that Voyager itself would later confirm. On August 25, 2012, Voyager 1 was almost 15 billion kilometers from the Sun when it sent back a signal that stunned mission control. The temperature around the probe had suddenly skyrocketed to nearly 50,000 degrees Celsius. How was this possible? More importantly, how was a spacecraft that had been flying for 35 years still functioning? Instead of being destroyed, Voyager 1 passed right through this inferno, completely unharmed, and continued its journey into the unknown. For a while, scientists wondered if it was a glitch. But then, 6 years later, in November 2018, Voyager 2 sent back the same data. At almost the exact same distance from the Sun, it too encountered this terrifying wall of fire. That's when it became undeniable. This wasn't a malfunction. It was a real permanent feature at the boundary of our solar system. This wall of fire has an official name, the heliopause. And yes, the temperatures there really do reach between 30 to 50,000 degrees, more than 10 times hotter than the surface of our Sun. So, the billion-dollar question is, how did the Voyager probe survive? The answer reveals one of the most counterintuitive principles in physics. You see, temperature in deep space is a completely different concept from what we feel on Earth, here. When we talk about high temperature, we're talking about the amount of heat energy being transferred. But out there, temperature is just a measure of how fast individual particles are moving. The particles at the heliopause are moving incredibly fast, which is why the temperature reading is so high. But this is the key: the density is incredibly low. There are only a handful of these superfast particles in every cubic centimeter. That's a vacuum 10,000 times emptier than anything we can create in a lab on Earth. Imagine being in space and encountering just a few drops of boiling water. Each drop is hot, but there are so few of them they can't transfer enough heat to actually burn you. That's what happened to Voyager. It passed through a region of extremely energetic particles, but there weren't enough of them to melt or damage the spacecraft. It was like a brief flash of radiation, but not a true inferno. So what creates this bizarre firewall? It all starts with the Sun. Our star acts like a colossal fan, constantly blowing a stream of charged particles called the solar wind out in all directions. This solar wind travels at hundreds of kilometers per second, inflating a gigantic protective bubble that extends billions of kilometers around our entire solar system. This bubble is called the heliosphere. The wall of fire forms right at the edge of this bubble, at the heliopause. This is where our solar wind, pushing outwards, collides head-on with the interstellar medium, the gas and dust that fills the space between stars. It's a cosmic showdown. The two forces clash, compressing and heating the particles to extreme temperatures, forging this scorching high-temperature barrier. But the heliosphere isn't a perfect sphere, because our entire solar system is hurtling through the Milky Way at 220 kilometers per second. The bubble gets squashed in the front and stretched out in the back like a giant comet sailing through the galaxy. The front end is about 100 times the Earth-Sun distance, while the tail could stretch out more than 500 times that distance. But the most shocking discovery was yet to come. As both Voyager probes crossed this boundary, they measured the magnetic field of the interstellar space outside. And what they found contradicted every single scientific model. The direction of the interstellar magnetic field was almost perfectly parallel to the Sun's magnetic field inside the heliosphere. Scientists expected them to be pointing in completely different directions. At first, they thought Voyager 1's reading might be a fluke. But when Voyager 2 crossed the heliopause from a completely different location and sent back the exact same data, the conclusion was inescapable. This discovery overturned everything we thought we knew about the edge of our solar system. It hinted at a deep, mysterious connection between our Sun and the galaxy that we are still trying to understand. The leading theory now is a phenomenon called magnetic reconnection. As the solar wind pushes outward, its magnetic field lines stretch and eventually snap, then reconnect with the magnetic field lines from interstellar space. This process not only heats the plasma to create the firewall, but also aligns the magnetic fields, preventing an abrupt change in direction. This discovery literally rewrote the textbooks. The edge of the solar system isn't a clean line. It's a messy, dynamic, and incredibly complex transition zone. And for us, here on Earth, this firewall is priceless. The heliosphere acts as our planet's cosmic body armor. It blocks more than 70% of the deadly high-energy cosmic rays that constantly bombard us from the Milky Way. These are particles that can tear through metal and shred DNA. Without this protective shield, life on Earth would be impossible. This discovery also comes at a perfect time. As we plan for future deep space missions and even interstellar travel, understanding this boundary is critical. We need to know how to design spacecraft that can survive crossing this barrier, and it raises a mind-bending paradox. Even though the Voyager probes have crossed the heliopause and entered interstellar space, they have not technically left the solar system. It sounds strange, but it's true. If you define the solar system by the sun's gravitational pull, then its true edge is the Oort cloud, a vast sphere of icy bodies that extends over a light-year away. At its current speed, it will take Voyager 1 nearly 20,000 years just to pass through the Oort cloud and reaching the nearest star. That's a journey of about 73,000 years. Sadly, these heroic explorers are nearing the end of their lives. Their nuclear power sources are fading. Around 2025, they will start shutting down their instruments one by one until they finally fall silent forever, drifting through the galaxy as silent monuments to human curiosity. Earth. But their story doesn't end there. NASA's upcoming Interstellar Mapping and Acceleration Probe, or IMAP, will build on Voyager's legacy, giving us an even clearer picture of this mysterious boundary. And the Voyagers themselves carry the golden record, a time capsule designed to last for 1 billion years, carrying the sounds and images of Earth to any civilization that might one day find it. This raises another fascinating question. If our sun has a protective bubble, do other stars have them too? The evidence suggests yes. The galaxy is likely filled with countless cosmic islands, each star system wrapped in its own invisible firewall, drifting through the galactic ocean. This means future interstellar travel will be challenging. Each time we enter a new star system, we'll have to cross another high-temperature barrier, and for larger stars, these firewalls could be far more intense. The heliosphere itself isn't static. It breathes, expands, and contracts with the sun's 11-year activity cycle. This is why the two Voyager probes, crossing at different times, encountered the boundary at slightly different distances. The heliosphere is like a living lung for our solar system. This whole journey of discovery, from a wild theory to a confirmed reality, has completely reshaped our understanding of our place in the universe. We are not just drifting alone in the dark. We're safely cocooned inside a vast, invisible firewall of boundary that not only protects us but also defines our home. It's a powerful reminder of just how complex, dynamic, and precious our corner of the cosmos truly is. Thanks for watching. It sounds like a paradox, but it's true. Solar system is far, far larger than we ever imagined. If we define its boundary not by the planets, but by the full extent of the sun's gravitational influence, then the Oort cloud is the true outer limit. This vast, ghostly sphere of icy bodies extends over 1 light-year from the sun. For perspective, at Voyager 1's incredible speed of 17 kilometers per second, it will take nearly 20,000 years just to pass through the Oort cloud and to reach the nearest star, Proxima Centauri. That journey would take about 73,000 years. Yet the harshest reality is this: both of these heroic spacecraft, Voyager 1 and 2, are nearing the end of their operational lives. Their nuclear batteries, the radioisotope thermoelectric generators that have powered them for decades, are slowly fading. Around the year 2025, NASA will have to begin shutting down their scientific instruments one by one to conserve what little power remains. Eventually, they will fall completely silent forever. They will continue to drift through the galaxy, alone, unseen, and unheard. Their signals will cease, and we will lose our most distant eyes and ears in the cosmos. But this is not the end of the story. In many ways, it's the beginning of a whole new chapter in exploration. NASA's upcoming probe UMAP, which stands for Interstellar Mapping and Acceleration Probe, is designed to extend the Voyager's incredible legacy. It will build upon their discoveries. deepening our understanding of this mysterious boundary region, the heliosphere, and its interaction with the interstellar medium. It's like passing the torch from one generation of explorers to the next. And even after the Voyagers fall silent, they will carry something even more enduring than their scientific instruments. They carry the golden record. This is a 12-inch gold-plated copper disc, an interstellar message in a bottle. It contains sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 languages. The sounds of wind and rain, animals, and a collection of music from Bach to Chuck Berry. The record itself was engineered to last for 1 billion years. It will continue its lonely journey, wandering the Milky Way long after humanity itself may be gone, carrying our story to any potential extraterrestrial civilization that might one day find it. It's a testament to our hope and our curiosity. This epic journey of discovery has led us to another profound question. If our sun has a heliosphere, this massive protective shield that interacts with interstellar space, do other stars have similar shields? The latest research suggests the answer is a resounding yes. It's very likely that many, if not most, stellar systems have their own protective bubbles, their own astrospheres. Imagine that for a moment. A galaxy filled with countless cosmic islands, star system wrapped in its own invisible firewall, all drifting through the vast galactic ocean. It's a beautiful and somewhat intimidating image. But this realization also means that future interstellar missions will face even greater challenges than we anticipated. Every time a probe attempts to enter a new star system, it will have to cross another one of these high-temperature barriers. The firewall around a star isn't just a passive boundary. It's a turbulent, superheated region of plasma. And massive hot stars may have even fiercer firewalls, potentially strong enough to disable a probe before it even gets close to the boundary. We're not just traveling through empty space. We're hopping from one protective bubble to another, each with its own unique and dangerous set of conditions. What's even more fascinating is that our own heliosphere isn't static, it changes over time. As the sun orbits the center of the Milky Way, our entire solar system moves through different regions of interstellar space, with varying densities of gas and dust. This causes our protective shield to expand and contract. It breathes. Over millions of years, Earth may have periodically been exposed directly to the raw, unfiltered interstellar environment. In fact, some scientists believe that around 3 million years ago, this planet may have experienced just such a naked exposure period. This could have had a profound influence on our climate, and even the evolution of early humans, bombarding our world with high-energy cosmic rays. Today, Voyager 1 is nearly 24.8 billion kilometers from Earth. It's so far away that it takes a radio signal almost a full day to travel from the spacecraft to us. It's currently heading in the general direction of a star called Gliese 445, though it won't get close for another 40,000 years. Its signal grows weaker with every passing day, but every single data packet it sends back is a priceless clue, a piece of a grand puzzle about the structure of our cosmic neighborhood. These findings from the Voyagers are now completely reshaping our model of the solar system. We've learned that the heliopause, the boundary where the sun's solar wind is stopped by the interstellar medium, isn't a simple, uniform sphere. Its thickness varies dramatically by location. It expands and contracts like a breathing lung, influenced by the sun's 11-year activity cycle. This finally explains why Voyager 1 and Voyager 2, traveling in different directions, encountered the boundary at different distances from the sun. The bubble isn't perfectly round. It's dynamic and asymmetrical, shaped by its journey through the galaxy. And all of this new knowledge is driving a new era of deep space engineering. The challenges are immense. Future interstellar probes must be designed to endure extreme plasma heating, navigate through intense magnetic turbulence, and withstand constant bombardment by accelerated particles. Every engineering breakthrough, every new material developed, every more efficient power source brings humanity one small step closer to becoming a true interstellar civilization. The dream of reaching other stars isn't just science fiction. It's an engineering problem we are actively working to solve. But perhaps the most important realization to come from this entire saga is this. Earth is not just a lonely rock drifting through the empty, cold darkness of space. We are gently and securely wrapped in an invisible firewall. Our sun has created a home for us, a protective bubble that shields us from the harsh radiation of the cosmos. This boundary protects us. It defines our place in the galaxy, and it serves as a powerful reminder of just how fragile, precious, and unique our world really is. The Voyagers have shown us the edge of our home, and in doing so, have given us a new appreciation for the incredible cosmic oasis we all share. Thank you for watching. If you enjoyed this journey to the edge of the solar system, be sure to like, subscribe, and follow for more adventures into the cosmos.